Let me first recall what we discussed about logistic regression. Let x be the feature vector. So all the inputs we call as feature vector. Okay, so this is in one sense the input, and so what will be the hypothesis function? Suppose y is the output. Okay, so y is the output. Now what is the hypothesis? Hypothesis means given the input or given the feature vector, what is your prediction about the value? Now in case of classification, you know, there can only be two values actually, 0 and 1. 1 means that something is present, 0 means something is absent. Like a mail is spam means 1, mail is not spam means 0. A student with particular CGPA will get placed means 1 and not placed means 0. Okay. So we have to create now hypothesis function. Recall that in case of linear regression, the hypothesis function was simply theta transpose x. Okay, simple linear. But now we have to classify. So our hypothesis function should be such that, you know, it should be lying between 0 and 1. Okay. So now, based on the discussion in previous class where we compared two probabilities, so now you forget that. Suppose even if you have not understood that, take this as a fact that we take e to the power minus theta transpose x, this as our hypothesis function. Now if you see mathematically, 1 divided by 1 plus e to the power minus z, what is the bound? So when z tends to plus infinity, so this term goes to 0, so this sigmoid function tends to 1. And when z tends to minus infinity, that is the lowest value, so this term tends to plus infinity, and 1 by infinity is 0, so this term tends to 0. So this function is bounded between 0 and 1, and it is indeed increasing function. So its plot looks like this sigmoid function. Okay, it's a perfect function for getting the hypothesis about classification. Now what is the decision we will make? So for any given x, if this h theta of x is greater than or equal to 0.5, then we take decision that y hat should be 1. Okay, and if h theta of x is less than or equal to 0.5 or less than 0.5, equality will be dealt with equal probability, so y hat equal to 0. Now let's look at this function 1 divided by 1 plus e to the power minus z. When is it 0.5? Okay, when is it half? So you can clearly see that for this to be half, e to the power minus z term should be equal to 1, right? When this is 1, it means z equal to 0. So at z equal to 0, this sigmoid function becomes 1 divided by 1 plus 1 by 2, which is 0.5. So if you look at here, so this is z, right? And at z equal to 0, the function takes the value half. And what should be then the decision boundary? So it is like for, so we decide if h theta of x is greater than or equal to 0.5 is same as this z is greater than or equal to 0. That is theta transpose x is greater than or equal to 0. So as long as theta transpose x is greater than or equal to 0, we decide that y hat is 1, the output is 1. If theta transpose x is less than 0, we decide y hat is 0. Okay, so these are some more details about logistic regression. Now what I told you in the previous lecture is, now if you have one unit, this is called one neuron basically. So what does this unit mean? It has some input, let's say this input, and you predict some output y hat. So this actually is the hypothesis function. It implements this hypothesis function, and in this case we are using the sigmoid hypothesis function, and so it is also called a logistic function, hence the name logistic regression. So when you give x, it evaluates this term and checks that if h theta of x is greater than 0.5, decide y hat equal to 1. If it is less than 0.5, decide y hat equal to 0. Now if you make a network of these neurons, this is what makes something called neural network. What does it mean? Suppose you have input has two features, let's say x1 and x2. Feed it here. Then this is one neuron, it will estimate the output based on this logistic function. So this output is fed to each neuron, next layer, and similarly here the output is fed to each neuron in the next layer. So these are called now layers. So this is layer 1, this is layer 2, this is layer 3, this is layer 4, layer 5. Then this neuron takes these two inputs and computes the output, and it feeds this output to all other neurons. Okay, similarly this feeds this to all other neurons. Then similarly next layer is there, so it's also computes this output. There are only two here. So then finally these two send the output to the last neuron called output neuron, and it makes a decision. The output can be more than one. Okay, suppose in case of computer vision problems it can be more than one. So this type of neural network is used for classification, and you have a single neuron, you can classify, but when you are using network of these neurons, which is called artificial neural network, this can do better classification in a robust way. Okay, let me recall first loss function also, or cost function. So you need a cost function such that if there is an error, so what is error? I repeat, if in actual data set, suppose for any jth term yj is actually 1, but your h theta of x for that particular data set point, suppose this is very small, it's closer to 0, then this is an error. So what does error mean? The cost should blow up, it should go to infinity. And similarly, if yj is 1 but h theta of xj goes to 1, that is decision is correct, then the cost should be as small as possible. Since we are taking only non-negative costs, so it can be 0. Similarly, if yj is 0 and but h theta of xj tends to 1, this is also an error. The function which computes error in such cases can be defined in this way. So you define this yj, then take a log of h theta of xj, but take minus sign. Why? Because h theta of x lies between 0 and 1. Log of any quantity between 0 and 1 is negative, minus makes it positive. Then minus, then you write here 1 minus yj log of 1 minus h theta of xj, just wait, and then sum it up for j is equal to 1 to m, 1 divided by 2m. So this is your j theta of m loss function. Okay, and sorry, j theta of x, and you know that to minimize it you need to find gradient of this with respect to x and put that equal to 0, right? And also I discussed it in the previous lecture that this minus log of x is a convex function, and it is basically a combination of two convex functions, and it will be convex. So the cost function in case of logistic regression is convex function. By the way, it is also called, this type of function is called cross entropy cost function. Cross entropy. Why it's called cross entropy? Because if you remember the definition of binary entropy, it is minus p log p minus 1 minus p log 1 minus p. If you see, it resembles this. The only difference is so here in case of binary entropy, the term here p and in the log is same, whereas in this case the terms are 0. That's why cross. So basically cross entropy in general, h of p cube is defined as minus q log p minus 1 minus q log of 1 minus p. So this is called cross entropy. Anyways, the name borrows from information theory. So the cost function of logistic regression is cross entropy. Now what is the cost function of neural network? Of course it is same. You see, in neural network, if you start at the output, so your output can be either 1 or 0, right? And take these two as inputs, right? So based on these two inputs you can use this same cost function here. Then coming to next layer, coming to this neuron, this is the output and these three are the inputs. Based on these three inputs you can compute the cost function. Similarly, at this neuron you can compute the cost function. In fact, in neural network we start from the last neuron, output neuron, and go on computing the cost function like this. Hence the name is called backpropagation algorithm. We will not do the details, but If someone is interested, he or she can read it. Back propagation algorithm, that is, minimizing the cost function but doing the computations from the last node rather than from the beginning. Okay, that becomes much easy. So let's do now some toy examples in the neural network to understand it. Now let's draw a very simple neural network. Suppose we have three inputs, okay, x1, x2, x3, and we will add here the bias point, if you remember, x0, which we always put equal to 1, so that we can show here. So that is also fed as an input to each of them. Okay, fine. And now this is called input layer. The first layer is called input layer, and this output is called output layer. Remember that these circles are neurons. What is inside the circle? What is this one neuron doing? It is doing exactly same what a single logistic regression unit is doing. Okay, now in between we will denote these in between layers. So this is the hidden layer, we call it. Okay, why it's called hidden layer? Because see, when you will be implementing neural network in Python, suppose you are interacting with the input layer because you are feeding the data set over there, input data set. Then, and you are also able to interact with the output layer. What you are getting will be the output. The inside thing is hidden to you. You don't see the interconnection. So that's why we call hidden layer. Now we denote the hidden layer parameters like this. So this is layer 1, L is equal to 1. This is layer 2, L is equal to, this is layer 3, L is equal to 3. So we use a parameter or the variable a, and the layer number we write here a2, and the number of neuron in this is 1. So a 2 2. So in layer 2, neuron number 2, a 2 3, right? So this is the simplest neural network we can have, and we can add here what we call as bias unit. Again, a0 of 2. You know that this a0 of 2 will always be 1. So this is meant so that the equation becomes symmetric. So this a, then the layer number is j and the neuron number is I. So this is also called, we say, as activation unit of unit I in layer j. So the neuron is also called the unit. And now we will have weights overall. You will have weights. Suppose you have from x1 to a21. For this you have the weight theta 1 1, right? Similarly, so suppose we start with x0. So we write the weight from this x0 to a21 like this. So theta. So first we write to which node it goes. It goes to the first unit, so theta 1. But where from is input coming from? The 0th unit, so 0, theta 0. And this weight is in the first layer, so we write here 1. Now let's try here. What will be? So this is theta 1 1 of 1, of course. Now coming to this point, you are having a weight to unit 1 in the second layer from unit 2, so theta 1 2, right, in the first layer. Similarly, what about this? You have theta, it is going to the first unit coming from third unit, so theta 1 3 1. Now suppose you want to write the weights when the output of this unit is fed to the input of the output layer unit. So what will be the theta? It is going to, so there is only one element here, so we will write 1 here, but it is coming from first unit, right? So theta 1 1, but at what layer? Layer number 2, right? So what will be this? Theta, it is going to 1 but coming from 2 at layer number 2. What is this? So theta, it's going to layer number 1 coming from 3 but layer number 2, right? So this way we can write it like this. And in fact we can write, suppose what is a1 of 2 is equal to, so what is the input? So in logic regression we write theta transpose x, but we know what is theta here. it is theta 1 0 of 1 with x0 plus theta 1 1 of 1 with x1 plus theta 1 2 of 1 with x2 plus theta 1 3 of 1 with x3. And we have to compute the sigmoid function over this. I represent sigmoid function with g. So with g of z equal to 1 divided by 1 plus z inverse, the e to the power minus z. Let me add one important point here, that in the recent research in artificial intelligence, several other such activation functions have been considered. You know, the sigmoid function which we introduced is called activation function in the jargon of neural networks. A function in some sense which activates a neuron. And there have been other activation functions also being considered, and the famous among them is ReLU, which is defined like g of z is equal to max value between 0 and z. That is, it is something like this. So till negative z, the max value is 0, and after z greater than 0, it is a linear line. Okay, so this is the ReLU activation function. There are other activation functions like tan inverse, but we will mostly concentrate on the sigmoid activation function. Now similarly, you can see what is the A2 of 2 doing. It is taking the input. How? It is taking the input like theta transpose x, but what is theta? Theta coming to the activation 2 from 0 at layer number 1. The input is just x0 bias there, plus theta 2 1 of 1 x1 plus theta 2 2 of 1 x2 plus theta 2 3 of 1 x3, right? And finally we can write also what is the output layer looking like, the hypothesis at output. So it is g of what is coming at the input, theta coming towards the first unit from 0 unit but layer number 2, so 2 here, plus theta going to first unit of the output coming from the first unit of the previous layer at layer 2, then a1 of 2. You see here it is a0 of 2. Of course a0 of 2 is always 1, plus theta 1 2 of 2 a2 of 2 plus theta 1 3 of 2 a3 of 2. Okay, so now you see this is the final output of this neural network. Now the decision will be made based on this. Suppose if you use this neural network, again very simple neural network, suppose if you use this for guessing about whether a student will be placed or not. X1 denotes CGPA, X2 denotes grade of some Python course, X3 denotes grade of some other math course. Let's say suppose there are 3 inputs only. So finally this h theta of x, if you use sigmoid function, it will lie between 0 and 1. So if its value is greater than 0.5, you decide that that you have the student will be placed. If it's less than 0.5, will not be placed, and you can make decision. But it is expected that this will make better decision because you are having a lot of neurons which are basically contributing in making that decision regarding this classification. Now let's try to construct a very simple neural network which will suppose implement some of the digital electronics operations, logical operations like AND gate, NOR gate. Let's start with AND gate. So what is the input? Suppose in this case the input will be either 0 or 1, right? And the output function is actually very well defined. It is x1 and x2. Now the input layer will have 2 inputs. Let this be x1, this x1 and x2, and we will have just directly the output layer. Okay, so in one sense it is simple logistic regression. So a neural network with just input and output layer is nothing but very simple logistic regression. Okay, now let's define the weights. So it will be theta 1 1, and there will be this x0 possibly. So this will be theta 1 0, theta 1 1, theta 1 2. Fine. And so if you define the x feature vector as this x0, x1, x2, and the weights vector as theta 1 0, theta 1 1, theta 1 2. So then what is the the hypothesis function is 1 divided by 1 plus e to the power minus theta transpose x, right? and we need to find the values of theta 10, theta 11, and theta 12 such that this neural network mimics like an AND gate. Let's take some values. Suppose, for example, you take theta 10 to be equal to suppose minus 30, and you take theta 11 to be let's say plus 20, and theta 12 you take as plus 20. Let's take these random values, and then let's see what will be the effect. You know that this x0 is always 1, it is a bias unit. Now what will be the value of h theta of x? All right, when we write here x0, I'm sorry, x0 is always 1, x1, x2. okay, now we have 0 0 0 1 1 0 and 1 1, right? So when both are 0, x1 and x2 are 0, so what is h theta of x equal to? 1 divided by 1 plus e to the power minus, so the first term is theta 10, so it is minus 30 into 1 plus 0 plus 0, so it becomes 1 divided by 1 plus e to the power 30. E to the power 30 is very high, so it is approximately equal to 0, so you can write here approximately 0. Now you take next, x1 is 0, x2 is 1, so what will be the value of this function? 1 divided by 1 plus e to the power minus, so first term is minus 30 into 1, this first term is actually theta 0 times x0. Then what is the next is theta 11 times x1, so theta 11 is plus 20, and x1 is 0, so plus 0 into 20, plus x2 is 1, so it is 1 into 20, right? So it becomes 1 divided by 1 plus e to the power minus 30 plus 20, right? And it becomes 1 divided by 1 plus e to the power minus 10, sorry, plus 10. So e to the power plus 10 is also a very large number. 1 divided by of that is almost equal to 0, so this is also approximately equal to 0. Let's take third round of input, in which x1 is 1 and x2 is 0. So what will be the value of hypothesis function? 1 divided by 1 plus e to the power minus 30 into 1, right? And plus 1 into 20 plus 0 into 20. So this is same as 1 divided by 1 plus e to the power 10, which is approximately 0. Fine. Now what if both are 1, that is x1 x2 are 1, so what will this hypothesis function become like? It becomes 1 divided by 1 plus e to the power minus 30 plus 20 plus 20, so and there is minus outside, so 1 divided by 1 plus e to the power minus 10. So e to the power minus 10 is very small, so this is approximately equal to 1. So hence in case of